In this video, we're going to have a look at how to solve equations that have the modulus function in, and we're going to look at a common mistake that students often make. To begin with, I'm going to solve this equation incorrectly, making a common mistake, and then we'll have a look at what you should do. Okay, here's our equation on the board. What a lot of people do is, from here, we need to get rid of the modulus function. So they make two equations. One using the positive version of this, and the other using the negative version. Okay. And then they solve each equation. So let's have a look at what we get. Here we get x equals minus 5, and here we get x is 5 over 3. Now, there is something wrong with what I've written on the board. So I'm going to record both answers and then we'll solve the equation properly. Okay. What you should do when you're solving equations that have the modulus function in, most of the time, is sketch the left hand side and the right hand side and use your sketch to inform how you solve the equation. So to begin with, let's sketch this. Okay, x minus 5. Well, I'm just going to draw it without the modulus to begin with. That's x minus 5 as a line, and if you want the modulus around it, whatever's below the x-axis gets reflected up. So this is at minus 5. It's now going up to 5. That's 5 there. Brilliant. Okay. That's y equals x minus 5, and I'm also going to label this line, which is the negative of that. But together it is y equals mod x minus 5. Cool, sketch the left side. Now I need to sketch the right side. Y equals 2x. Little bit wonky. There we go. Okay, now as you probably know from AS Maths, the points of intersection of these two curves, or these two lines, is the same as the solutions to this equation. So we just need to find the points of intersection. How many are there? Well, there's one there for sure. So let's quickly grab that. That's where 2x equals minus x plus 5. So we get 3x equals 5. Brilliant. There's one solution. And then the question is, do they cross again? They certainly don't on my graph, but maybe I haven't drawn the graph big enough. But you might be able to tell. Just have a look at these two lines. Will they cross eventually or not? The gradient of this line is 2. The gradient of this line is 1. This line is steeper. So as they move to the right, they're not actually going to intersect again. Which means there is only one solution to this equation, not two as I originally worked out. That's why drawing a graph is very useful to help you solve equations that have the modulus function in. There are other ways to do it, but I really prefer this way in terms of sketching graphs. Some of you may realise that the other thing you can do is perhaps sketch it for the positive and the negative. Excuse me. The other thing you can do is just do what we did in red. Solve it for the positive version and the negative version. Get your two solutions and then just check they work. So sub 5 over 3 in. Does the left equal the right? Yep, it does, all good. Sub minus 5 in. Does the left equal the right? No. Chuck it out.